Now let's talk about finding the derivative of trig functions. All right, so all it really amounts to is knowing what the derivative of the different trig functions are. So I think in this video, we're just going to talk about the derivative of like main trig functions. I'm not going to go into inverse trig functions here because just because, make the video a bit longer to cover all of that because it's a bit to cover, but it's not complicated. But anyhow, so when you find the derivatives of trig functions, let's go ahead and go through that. And by the way, you can download these notes on my website. When you become a subscriber, you get an email that gives you access to my downloadable notes that I create whenever I do these videos. All right, so the derivative with respect to theta, I didn't mean to put an equal sign there, of sine is cosine. The derivative with respect to theta of cosine is negative sine. The derivative with respect to theta of tangent is secant squared. So now let's go to the co-functions, so to speak. So the derivative with respect to theta of cosecant is equal to negative cosecant. So negative cosecant cotangent. The derivative of secant is secant tangent. And finally, the derivative of cotangent is going to be equal to negative cosecant squared. All right, now, so basically when it comes to finding the derivative of trig functions, these are the derivatives of trig functions. So it'll be a good idea to memorize these. And the more problems you do, it'll be easier to just kind of like automatically memorize them. But the other thing to keep in mind is to remember your trig identities. Trig, put the dot in the wrong place. Remember your trig identities. Oops, oh well. So trig identities. Because what happens is when we kind of start getting to this trig stuff, remembering the trig identities will actually be very crucial in helping you to simplify problems that have trig functions in them where you're taking the derivative. Now, you're not always going to need to remember those, but let me just go ahead and write them here. So like, what's it? Cosine squared plus sine squared is equal to 1. Then you got 1 plus tangent squared is secant squared. And 1 plus cotangent squared is cosecant squared. All right. So, and there are other, things in there that you could perhaps remember, but those will be key in helping you to kind of, simplify some of these different types of problems whenever you get to situations where you have like a identity that can be used or whatever, and simplify your problem, help you to make sure that you actually get a correct simplified answer. All right, so let's go into just a couple of examples, a few examples, I guess is the way to put it. So first, let us do the following. So derivative of 4 sine 3 theta. All right, so the derivative of 4 sine 3 theta. So check it out. The thing to recognize here is that you're taking the derivative of a constant times the sine of something. Now, the fact that and this is with respect to theta. So the fact that this actually has a 3 in front of there we need to take the derivative of the inside here too. Now, if it was just theta, the derivative of the inside would just be 1 because you have because the theta is like a variable. So 3 theta, think about that. So let me just write it down so I'm not just talking. So the derivative of theta is just like the derivative of, imagine that this is a variable and that's theta to the first power. And so that would be 1 theta, and then 1 minus 0 is 0. So that would just be 1. So if it was just theta, you're really taking the derivative of the inside as well, chain rule. But if it's just theta, the derivative will be 1 anyway. So it kind of doesn't really matter. But it's 3 theta. So we're going to use the chain rule, which remember is the derivative of the inside times the derivative of the outside, okay? All right, so that is going to be, let me see, sorry, I want to erase this here. All right, so you want to take the derivative. So I'm actually going to do it in the reverse order. So first, you'll do the derivative of the outside. It doesn't really matter because multiplication, it doesn't really matter the order. So the derivative of the outside. So we're just going to treat this. You can say, if you want to, if it helps you, you can do like people usually do and just say 3 theta is going to be equal to u. So the derivative of 4 sine u will be 4, and then what's the derivative of cosine? So remember that constant just stays there because technically, how do I say this? So if you're taking, the constant, well, yeah, I won't even go into that a lot. The main thing is just that this constant stays on the outside. Just like if you had, how do I say this? Just like if you have like a 4x or something like that, and then you take the derivative, first times the derivative of the second plus the second times the derivative of the first. So you're going to keep that there. So anyway, what's the derivative of sine? That's going to be cosine. Like I said, you can use u if that helps you. I'm not going to do that because when I learned, I learned the u stuff, but I just usually practice it without it. So derivative of the outside times the derivative of the inside. So the derivative of 3 theta is going to be just 3 because you got 3 times theta to the first power, bring that 1 out in front, and then subtract 1 from the exponent. So that goes to 0, which anything to the 0 power is 1. So you're left with 1 times 3, which is just 3. So simplify this, it's going to be 12 cosine 3 theta. All right, let's do another example. The derivative of secant theta tangent theta. All right, so now this is product rule because you have functions being multiplied times each other. The first times the derivative of the second plus the second times the derivative of the first. So let's do that. So the first times the derivative of the second, the derivative of tangent is secant squared, plus the second times the derivative of the first. The derivative of secant is secant tangent. So that's going to be equal to secant cubed plus secant tangent squared. Okay. Here, let me see something here. If there's anything else I want to point out here in these notes. Okay. So that's fine. So yeah, now look at this here. Oh, where's my, okay, here we go. So what I looked for when I was solving this problem right here, I did a quick look over to see, can I find any, can I use a trig identity to simplify this? So, but you really can't because 1 plus tangent squared is secant squared. Now, what you could do is you factor out a secant from each of these, so then that would leave you with secant squared plus tangent squared, but that does not match up with this identity here. Okay, so technically you could say secant squared minus tangent squared is equal to 1, but we have secant squared plus tangent squared, and so that doesn't really Identity doesn't help us. All right, one more example, and then I'll let you guys go. Just remember, when you have a constant in front of like the function like that, the constant just it just stays there. All right. Okay, so I'm actually going to erase a lot of this stuff here just to make sure I have enough space to solve stuff. So again, if you want to download my notes, just subscribe to mathswaptutoring.com. Just put a / subscribe on there, and I'll leave it up there. And then you should get a code to download my math notes, and you'll find the notes on finding the derivative of trig functions, and you'll have all those derivatives of the trig functions there. They should also be in your math notebook. All right, so the derivative with respect to theta of 1 plus sine theta over cosine theta. Now this is quotient rule stuff. The bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And I should have a video on this somewhere on the channel, so look for that. Yeah. All right, so let's do that. So bottom times the derivative of the top. So bottom times the derivative of the top. The derivative of 1 is just 0, so that goes away. The derivative of sine is cosine. So that's bottom times the derivative of the top minus the top times the derivative of the bottom. Remember, the derivative of cosine is negative sine. All of this is over the bottom square. All right, so now let's pull all this stuff together. So you got up here, you got cosine squared. And I'm gonna multiply these first, and then later in another step, I'll distribute this negative. Keep track of your negatives for sure. All right, so this is gonna be minus, now let's distribute this through here. So that's gonna be negative sine theta minus sine squared theta over cosine squared theta equals cosine squared theta. Now let's distribute the negative, so that's going to be plus sine theta plus sine squared theta over cosine squared theta. Now look, you got a cosine squared and a plus sine squared over here. Trig identity. So this plus this is going to be 1. So these are going to go to 1, and you'll still have that plus sine theta up there. So this becomes 1 plus sine theta over cosine squared theta. All right. Oops. So anyhow, trying to draw that box around there without messing up. But yeah, so there's the answer. So you see that, there are definite values for the separate trig identities. And then also you're going to use product rule, quotient rule, chain rule, trig identities, all that type of stuff. Remember, I have notes on my website for my subscribers. So anyhow, I hope this video was helpful. And make sure you also look for my video that is going to be up on quotient rule, as well as a video up for finding the derivative of trig functions, trig inverse functions, okay? All right, y'all.